Hey everybody, so we are now on our last unit before the algebra placement test. So this is chapter 5, and the focus of chapter 5 is going to be for us direct proportion. Do not worry about inverse proportion. That's actually something that you study in algebra. So when you look at what we have this week, just kind of, not this week, I guess the next couple of weeks, what we have going ahead is lesson 5.1, understanding direct proportion. 5.2, representing direct proportion graphically. Number 3, solving direct proportion problems. And we are not doing 5.4, which is understanding inverse proportion, because that is an 8th grade standard, or you will be doing it in Algebra 1. So what I would recommend, though, is that you open up to page 248, which is lesson 5.1. And I would have your book next to you as I'm doing my instructional videos for the next couple weeks, because a lot of direct proportion has to do with graphing and tables. You'll already see on the first one we're going to be doing a table. And although I'm trying to represent it here, they definitely have more images and more supportive information and graphics for you in the textbook. So please have your textbook handy. I'll always indicate what problem we're working on. And then, of course, pause it. If you're not understanding something, look in the book, replay the video, but take your time. But I do have to say, I feel like this concept is going to come fairly quickly to many of you, because essentially direct proportion has to do with equivalent ratios and unit rate, which are two concepts that you have already done as part of your 6th grade standard. So I actually feel like between your knowledge of ratios and unit rate, you are going to pick up this concept fairly quickly. But of course, as always, if you need help, that's what I'm here for, and please let me know. So this is, we're on page 248. And this is where it says you have strawberries for $2 a pound. So at a grocery store, each pound of strawberries costs $2. I'm hoping that for many of you, you're saying, ding, 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 it's $2 each pound. I'm going to pause the Ed puzzle and ask you to tell me, is that an equivalent ratio or is that a unit rate? Each pound of strawberries costs $2. Is that a unit rate or an equivalent ratio? Pause. All right, now you're back. Hopefully you said that this is a unit rate, because each pound costs $2. So that is, remember, per pound. We talked about how many gallons per mile. We did all that work around per or each, which is unit rate. So unit rate, when we're talking about direct proportion, is the same as a constant, which you're like, what are you talking about? Although you should have seen it in the vocabulary video. We will talk about constants as part of the equation with direct proportion, and a constant is the same as a unit rate. So let me say that again. A constant in direct proportion is the same as a unit rate. And a constant in direct proportion is represented by the letter K. Kids ask me every year, why is constant not represented by the letter C? I don't know. I have no idea why, but it is K stands for the constant in a direct proportion, which is also the unit rate. So up here, we know that the constant should be $2, meaning that in these equivalent ratios, it should be going up by 2, which you'll see on the graph. If this is a direct proportion, it would be going up the same amount. So the thing with a direct proportion, as you heard from the flowcab video, is it needs to go from the center of the origin, which I will have you say on the Ed puzzle, what ordered pair, and ordered pair is like X comma Y. What do you think the ordered pair is for the point of origin? I'm going to pause this and let you, hopefully you have the answer for that. What do you think the ordered pair is if the line goes through the point of origin? Pause, come back. Hopefully you said 0, 0. So the point of origin is right there. And in a direct proportion, a point of origin, a line, when you're graphing it based on the order of pairs, goes through the point of origin. So a line, it can't end here. or it can't graph and end there. It always goes through the point of origin, 0, 0, and it's always a straight line if it's a direct proportion. So it always goes through 0, 0, and it's always a straight line. So remember in the FlowCAD video when he got a tip, the line kind of went like, that would not be a direct proportion, right? Because when you graph it, hopefully, in a direct proportion, it goes through the point of origin and it's a straight line. But I get ahead of myself. Back to the table. So what does this have to do with equivalent ratios? So let's check this out. If I said that this was a ratio of 1 to 2, and this is a ratio of 2 to 4, and this is a ratio of 3 to 6, what do you notice about those three ratios? Pause. Answer an ed puzzle. Come back. Hopefully you said these are all equivalent ratios, right? And they can all be reduced to this 1 to 2, right? Because 2 can go into 2 once, and 2 can go into 4 twice. 3 can go into 3 once, and 3 can go into 6 twice. So these are all equivalent ratios that can be simplified or reduced to this first example. So with that knowledge that these are equivalent ratios, 1 to 2, 2 to 4, 3 to 6, what's going to be here? What do you think your y term, or is going, y, the y, we call it an ordered pair, but what do you think the y term will be? If this is 4, what should this be to make an equivalent ratio that can be reduced to 1 to 2? Pause. Come back. Hopefully you said 8, right? 4 to 8, because 4 can go into 4 once and it can go into 8 twice. So one way that we can check if something is a direct proportion is by checking to see if the ordered pairs in the table all are equivalent ratios. So that's one way that we find or identify direct proportion. If they can all be, if they're all equivalent ratios that can ultimately be reduced or simplified to the original ordered pair. Another way we can do it is using this formula y equals k x. And in this, the weight of the strawberries is the x, right? Because when we multiply, our constant is 2, right? That's our given, that's our unit rate. So I'm putting in the $2. X is the number of pounds that would actually make the y work. So X is our, we talk about a dependent and an independent variable. In this case, X is our dependent because whatever y is going to, is our independent, whatever y is equal to is going to be based on what we multiply the x, the independent variable. So in this case, this first one, x is 1, and hopefully 2 times 1 is equal to our y, which is our cost. And why that is the dependent variable is you only know y, it's dependent on how many of the x that you bought, right? So in this case, it's pounds of strawberries. In the FlowCAD video, it was how many hours he worked, right? So in the hours he worked, the x would be the hours, right? Because if he worked 1 hour and he got $10 an hour, then your y would be 10. If he had worked 2 hours, your y would be 20. So your y is dependent. It's dependent on what your x is. Your x is your independent. It's the one that you multiply your constant by, and then your y is dependent on whatever your x was times the constant. We'll go over independent and dependent in the later units, but I kind of wanted to get that language out there for you right now. But still using this formula, I've got my k is 2, so x. And this one I'm going to say x is 2. So hopefully our constant times our x should be equal to our y, which is 4. So that worked. Here, our x is going to be 3. So we're multiplying 3 times our constant, which was $2. And of course, 3 times 2 is 6, which is what our y was in the chart. And then our last one, our constant, is $2. We multiply that by the independent variable, but we had 4 pounds of strawberries. 4 times 2 is 8. And of course, our dependent variable, our y, was 8. So we know that when we use a y equals k times x, all of these were equal to each other. So that's another way that we check if it's a direct proportion or a proportional relationship. The last method we use, so we've used the equivalent ratio method, we've used the y equals k times x method, which is our dependent times our constant and our independent variables. The last one is our constant, k. Our constant should be equal to y divided by x. So typically in the tables, x is above y. That's just how tables are represented. But you do have to think about which one, again, independent and dependent. We're going to get into that more as we keep working on this. But most of the tables in the beginning are nice and kind, and they label for you if it's a y or an x in the table. So x and y. X is the weight of the strawberries, and cost is the y. So in theory, the constant, which we know is $2, that's a unit rate, should be equal to y divided by x. So in this case, it's 2 divided by 1. In this case, it's 4 divided by 2. In this case, it's 6 divided by 3. And in this, it's 8 divided by 4. And of course, all of these, 2 divided by 1 is 2. 4 divided by 2 is 2, 6 divided by 3 is 2, and 8 divided by 4 is 2. So in all of these examples, they were equal to the constant, or k, which is why it worked. The fourth way, so we've learned this is a way to check direct proportion. We've learned this formula as a way to check direct proportion. We've learned this formula as a way. The final way is by graphing. So if I go over here and say my x is on the 1 and my y is on the 2, I'm going to put one there. And then my next one, my x is on the 2 and my y is on the 4. I'm sorry, I know I should have grid lines, so it's a little off. My next one, so x is 2, 4. All right, my next one was 3 to 6 and 4 to 8. And I know it's not completely perfect, but I have a line that's a straight line. It's going through the center of origin. So that's another way that we check if we have a direct proportion relationship, because it should be going up by the same amount, which is, of course, that constant, right? As my x goes over 1, my y goes up 2. As my x goes over 1, my y goes up 2. As my x goes over 1, my y goes up 2. X goes over 1, y goes up 2. That is actually called slope. I'm not even going to get into that with you right now, but this is all direct proportion is getting you ready for algebra and the concept of slope. And that's what's happening when it's something called rise over run. And if you want to spend some time this summer checking it out before you get into algebra, you can. But this is what direct proportion, just to let you know where we're headed for next year, is really what you're talking about with slope when you're doing algebra. So a lot of information. Let's just go through now and try some problems. All right, I'm going to pause and get drawn up for the next problem. Okay, so I am now on page 251. And we're on example number 1, tell whether quantities are in direct proportion from a table. So a pet store owner uses a table to decide how many of a certain type of fish to put in an aquarium. Tell whether the number of fish is directly proportional to the volume of water, g gallons. If so, give the constant of proportionality, which that's what we talk about with our constant, right? So they are not giving us the constant like they did in the last problem. Remember, the last problem told us the unit rate. They told us it was $2 per pound. They did not tell us what the unit rate is. But we will be able to find the unit rate because of this formula. So that's why you end up needing to learn this formula, is if they don't outright tell you the unit rate, you do have to use the information in the table to find the unit rate. But using that formula, you'll be able to. So if it does, if so, give the constant of proportionality, tell what it represents in this situation, and then write a direct proportion equation. And that's what we have here with y equals k times x. So how do we find out if it is a direct proportion? Well, the first way that you want to check if it's a direct proportion is finding out, are they equivalent ratios? So if I have 4 to 6 here, 4 to 6, if I have 10 to 15, and I have 20 to 30, can these all be reduced or simplified to the same equivalent ratio? So what do 4 and 6, can they be reduced? Well, I'm like, I know 2 goes into both of these, so I end up getting a 2 to 3 ratio. In this case, 10 to 15, I know that 5 can go into both of them. 5 goes into 10 twice. 5 goes into 15 3 times. Look here for equivalent ratios. What can go into 20 that can also go into 30? And first I'm like, oh, I know 5 can go into both, but that won't fully simplify it. So what goes into 20 that also goes into 30? Well, 10, right? 10 goes into 20 twice, and 10 goes into 30 3 times. So the first tip I would tell you when you're trying to identify if something has a direct proportion, check all of the ordered pairs or the relationships in the table. Don't be like, oh, it does in the first one, because in future ones they're going to try to throw you off and they're not going to be equivalent ratios. So make sure you check all of your ordered pairs. You check your x and your y in this one. You check your x and your y here, and your x and your y here. And right now, we're right. It has a 2 to 3 relationship. So they are equivalent ratios. So there is a direct proportion relationship here. So we have figured out that, yes, there is. But the next thing that they asked us is, if it is a direct proportion, find out the constant. And we don't know the constant because they didn't tell us in the problem, like they did with the strawberry one, how many dollars per pound, I think it was, in that one. So how do we find the constant? Well, k equals y divided by x. K equals y divided by x. So in this example, my y was 6 over 4. So k was equal to 6 over 4, which is the same as 2 thirds. In this one, k was equal to 15 over 10, which of course, did I miss that? 6 goes into 3 twice. Did I reverse these? This is Sayward. Oh, sorry about that. 3 over 2, I'm sorry. If we were in class, you would have corrected me. 6 divided by 2 is 3, 4 divided by 2 is 2, that's why. Same thing here, 15 divided by 5 is 3, 10 divided by 5 is 2. I go over here, k equals 30 over 20, and of course 30 over 20 can be reduced to 3 over 2. So all of these proved that our constant of proportionality, our k, is 3 over 2. So what does 3 over 2 represent? 3 over 2 is saying, like in this example here, because we did our y over x, right? It is saying for every, because it's y over x, for every 3 fish, we need 2 gallons of water, right? So for every 3 fish, we need 2 gallons of water. For every 3 fish, we need 2 gallons of water. 3 fish, 2 gallons of water. Now, obviously, you don't have, you're like, oh, well, that can be reduced to 1.5, right? It isn't like, oh, it's 1.5 fish is our answer. That's not what it's saying. A direct proportion or proportional relationship is so you could project and say, all right, well, if I wanted to have 45 fish, that's a lot of fish. I wanted to have 45 fish, because my K is equal to Y over X. What would this need to be? Again, we're back to equivalent ratios. What would this need to be in order for this relationship to work? I'm going to pause the video in the Ed puzzle. You can tell me how, if I have 45 fish, how many gallons, what's the volume of water? How many gallons of water am I going to need? Hopefully, you put in that you would need 30 gallons of water, right? Because 45 divided by 15 is 3, and 30 divided by 15 is 2. So I would go back to that same constant of proportionality, that same unit rate. So it's, in this case, what we're doing with the direct proportion is projecting and saying, okay, if I want to buy 45 fish, I need 30 gallons of water. So that's our constant. 3/2 is our constant of proportionality. And I think the last thing it asked you to do was write a direct proportion equation. And that's where we go to, and unfortunately, there is an aspect of you're going to just need to memorize these formulas, but the direct proportion equation is Y equals K over X. So when they talk about the direct proportion equation, it's this same equation, Y equals K times X, but you swap out the variables that are worded in the question. So in this case, our Y equals F, right? Y was our fish, our number of fish. So number of fish is equal to, you plug in your constant, 3/2, and then you plug in the variable for X, which was G. So F equals 3/2 G. So when they ask you to write a direct proportion equation, what you need to identify is the constant, and then you use the variables that are specific to that problem, which was F for fish equals 3/2 G for gallons. So I had talked to you about which one's the independent variable and which one is the dependent variable. So it makes sense in this problem, X is our independent variable, right? The volume of water, how many gallons you have, is independent, right? Because the number of fish you have depends on how much water you have. The fish are going to die, right? They're dependent on how much water they have to live. So the independent variable is the water. That's the one that stands alone. The dependent, the one that matters on the situation, is the fish, because if they don't have enough water, they're not going to survive. So in this case, again, water is our independent variable and fish is our dependent variable. And of course, the last way that you can check proportional relationships is by graphing. And it's not ideal for me to be graphing on a whiteboard without grid lines or anything, but I'm trying to show you how this works. So with an X, Y, so our first ordered pair is X is 4 and Y is 6. So I go 4 to 6 and I'm eyeballing this. My next one, my X is 10, and I'm guessing it's about here. Again, not ideal, I apologize. And then my 20 to 30 is about here. So in a direct proportional relationship, if I connect this line, ideally, sorry, I missed that one, I graphed it, but you knew where I'm headed, you can see it's crooked. Ideally, with a direct proportion relationship, you've got a straight line, and of course it goes through the point of origin, all right? I know this is a long video. We're gonna try one more example, and then you're gonna do a couple on your own. The good news is this is the one Ed puzzle video, and I know it's longer than usual, but these are some new concepts, so I apologize. Hopefully you can pause the video, come back to it if you find a half an hour too long. Pause it now and come back to it, but we have one more problem I'm going to teach you before you do a couple examples on your own. Okay, so the last problem that we're going to do as part of this ed puzzle is on the bottom of page 251. So the table shows the distance traveled by a snail. Distance traveled is d centimeters. After t hours. Tell whether d is directly proportionate to t. If so, give the constant of proportionality and tell what it represents. And then finally, write a direct proportion equation. So we're trying to figure out, does this have a direct proportional relationship? So remember, the first thing I tell you to do is look for equivalent ratios. So we're looking here, and if we have, like, it's a 1 for every hour, 9 centimeters. For every 2 hours, 18 centimeters. And for every 3 hours, 21 centimeters. So I have set up equivalent ratios are x to y. How many hours to distance? Hours to distance, hours to distance. So 1 to 9, I can't reduce that anymore with the 1 there. So 1 to 9, 2 to 18. So that can be reduced. This is looking good, right? 2 goes into 2 once. 2 goes into 18 9 times. So look at 1 to 9. So yeah, direct proportion. This is awesome. Woohoo! All right, but don't quit. Third one, 3 to 21. Does anyone see a problem? Hopefully. You answered yes, because 3 to 21 can be simplified. 3 goes into 3 once. 3 goes into 21 7. 1 to 7 is not the same as 1 to 9. So if I had not checked this last one, I might have said it is a direct proportion, that they do have the same constant. But in fact, this is not a direct proportion relationship, because for 1 hour, the snail went 9 centimeters. For 1 hour, it went 9. Well, on the third hour, it only went 7. So it did not maintain the same distance traveled, right? It did not maintain the same K. So to double check this, how could we check what? Well, K is always y divided by x. So y divided by x, in this case, y is 9 and x is 1. So we get 9. This one is 18 divided by 2, but we know that that is the same as saying 9 divided by 1. And this last one would be 21 divided by 3, but of course we know that that would be the same as saying 7 over 1. So they do not have the same constant of proportionality. So you can actually stop there. You don't have to do a direct proportion equation, because this is not a direct proportion. I did pose this question though. What does K represent when we looked at these? Well, K would have represented, in this hour, the centimeter went the 9, right? We're talking about speed, right? The distance traveled, that it was averaging a speed of 9 centimeters per hour. So that was giving the average speed. That's what our constant is representing, which it does make sense, right? That the distance traveled, your y, is dependent on your constant, your speed, times your x in this case, which is time, right? Your distance traveled, y, does matter when you multiply your constant, your speed, times time, right? Remember we learned that when we did our distance equals speed times time, right? How far you go, your distance depends on your speed and your time. So it's bringing it back to all of that good stuff that we did with unit rate, right? So our constant, like our ending things before you do the next couple of problems are, first, look at the relationships in the table and see, are they equivalent ratios? If you cannot simplify them down to an equivalent ratio, it's not a direct proportion. You then, if it is a direct proportion, if they don't tell you what the constant is, you can find the constant. Constant is equal to your y divided by your x. Your y divided by your x. And when they tell you a direct proportion equation, They want you to plug in the value for your constant and then just put in the variables for what your y and x represent in that problem. And just remember, K stands for constant, which is also your unit rate. Okay, 30 minutes. I know it was a long ed puzzle, a lot of information. Do your best. And of course, like I said, email me if you're really stuck or you're not understanding, but we're going to be doing this for the next couple weeks. So you are going to do awesome. I have total confidence in you. All right, bye.